To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all questions related to current electricity. So in the lesson, we started off the lesson by discussing what static electricity and current electricity are. So basically all matter are made up of atoms and they have charged particles and electrons. The negatively charged particles of the atoms can be removed from the atom and they can move. So because of that, components can become positively charged or negatively charged. And if the charges that form on the surface of insulators do not move, then we call it static electricity. If the charges flow, then it becomes current electricity. Then related to current electricity, we discuss what current, potential difference, electromotive force and resistance are. Then we combine the relationship between potential difference, current and resistance to give rise to the Ohm's law. Thereafter, we discussed resistors, factors that affect resistors, the type of resistors, and also we saw how we can combine resistors together in a series combination or a parallel combination. So now, I'm going to discuss the questions given in your textbook first. I'm sure you all would have already answered these questions. If not, do it by yourself first and then you can listen to my discussion. Thereafter, when I start the extra questions also, you can look at the slide, you can answer the question first and then you can listen to the discussion and check your answers. So, exercise 19.4. The first question, Ruwan needs a resistor of 3 ohms and another one with 40 ohm. So you know these have to be fixed value resistors. If you have a rheostat or an adjustable resistor, variable resistor, you can adjust it to any value. But when they say a particular resistor with a fixed value, then it refers to the fixed value resistors. But he could only find some resistors with resistances of 20 ohm and 9 ohm. So that confirms it. 20 ohm fixed value resistor, 9 ohm fixed value resistor. So then, briefly explain how you could make a combination of resistors having a resistance of 3 ohm. Now you can remember students, when we looked at the two combination of resistors, when we combine the resistors in a series combination, how do you find the equivalent resistance? The sum of the resistors. Say if you have 20 ohm and 20 ohm, the addition of 20 ohm plus 20 ohm, so the equivalent resistance will become 40 ohms. So that will increase, the resistance of the circuit will increase. But when you have a parallel combination, what will happen there? The resistance will decrease. You can remember 1 over R, 1 over equivalence resistance is equal to 1 over R1 plus 1 over R2. Since you add the reciprocals of each individual resistors to find the reciprocal of the equivalent resistance, then when you get the reciprocal of that value, the equivalence resistance will be less than the other values. So if you want, now see, you can see here 3 ohm and 40 ohm. So 3 ohm is less than 9 ohm, whereas 40 ohms is more than 20 ohms. So accordingly, you have to select the combination. The first question is to briefly explain how you could make a combination of resistors having a resistance of 3 ohm. So you can see 3 ohm is less than 9 ohm and 20 ohm. So now 20 ohm is an even number. By looking at these itself, you can get an idea. If you combine 20 ohms in a series manner, obviously it will be more. 9 ohm in a series manner, it will be greater than 9 ohm. So we have to go for a parallel combination, and in that also you have to select. So if we first try that out, now here you can see if we have a connection like that, if you have like that, if you take 1 over r as 1 over 20 plus 1 over 20, obviously it will be a high value. This will become 2 over 20. So therefore r will be equal to 20 by 2. So that's going to be just 10 ohm. Even if you have 3, it will be 20 divided by 3. So you can, I have told you all this. For convenience, you can use these short methods, but for the answer, you have to explain it properly. So by looking at the values, now if it is a 20 ohm resistor, if you have 2 of those, the value gets divided by 2. So 20 divided by 2, 10. If you had 3 resistors, 20 ohm resistors, then the value will get divided by 3. 20 divided by 3. So that will be about 6 point something. If you divide 20 by 4 resistors, that will give you a equivalence resistor where you divide 20 by 4. So 5 ohms. Like that, even if you try, you won't get the 3 ohm resistor. But instead, if you use the 9 ohm resistor, so from the value 3 and 9, 3 times 3 is 9. So there you can easily identify if you had 3 resistors, because 3 times 3 is 9. So if you connect 3 9 ohm resistors in a parallel manner, the resistance will be divided by 3. That is how you can quickly come to a conclusion. So there we will need to have 3 resistors. We will have we will have 9 ohm, 9 ohm. If you only have 2 9 ohm resistors, it will be 1 over 9 plus 1 over 9. So it will become 2 over 9. If you divide 9 by 2, it's only going to be 4.5 ohms. So you need to have 3 resistors. 9 ohm. So then, if you find the equivalence resistance, now you can see 1 over 9 plus 1 over 9 plus 1 over 9. So denominators are same. So the numerators 3, 1 plus 1 plus 1. So to find R, you will need to take the reciprocal. 9 over 3, it will be equal to 3 ohms. That is how you can easily identify how to combine resistors. Look at the value, try to identify whether it's a multiple. But if it is a different value, something where you don't have a multiple, then you will have to go for different combinations. You will have to try out the value. But here, if it is a simple value like that, where you get a multiple, then it is easy for you all to identify. So since we have 9 ohm resistors, but we need 3 ohm equivalent resistance, you need to find the relationship. 3 times 3. So you will have to connect 3 9 ohm resistors in a parallel manner. Then you will get the equivalent resistance of 3 ohms. Is that clear, students? So now that you have understood the method, we will write down the answer. So here, briefly explain how you could make a combination of resistors having a resistance of 3 ohm. So here we can say connect 3 9 ohm resistors in a parallel combination. And to show that your answer is correct, we can show the calculation. 1 over R equals 1 over 9 plus 1 over 9 plus 1 over 9. That is equal to 3 over 9. So therefore R is equal to 9 over 3 ohms. So that is what you need to write. So always look at the values. I am sure you all can understand that. And remember, if you want a higher resistance, you need to connect the resistors in a serial manner. If you want to decrease the resistance, you have to go for the parallel manner. So you can see now 9 ohm resistors 3, but the resistance, equivalent resistance becomes 3. It decreases. I'm sure you all can understand that. Then the second question. Give a figure using symbols showing how you could make a combination of resistors having a resistance of 40 ohms. So that is again direct question, no students? Now we have a 20 ohm resistor. We need 40 ohms. Double the 20 ohm resistor. So if you can connect two 20 ohm resistors in a series combination, you can get an equivalent resistance of 40 ohms. So that is what you have to show here. So we need to use a diagram. Here we only show the combination of resistors. No need to show the other components because they just want us to show how the resistors are connected. So this of course, so 20 ohms, 20 ohms. Since this is a series connection, we can show the calculation for equivalent resistance. R is equal to R1 plus R2. Always write the equation before you do the calculation. That's very important. So R1 20 plus R2 20. That is equal to 40 ohms. Is that clear? So now you have seen both types of combination of resistors. We connect the resistors in a parallel manner. The equivalent resistance will decrease. So if you want to increase the equivalent resistance, you have to connect them in a series combination. And also from the value, you have to decide which one to consider. For a 40 ohm resistance, there's no point using a 9 ohm resistor or combination of 9 ohm resistors. It's difficult. This is the easiest method. The same goes for the previous one. Because you need a 3 ohm equivalent resistance, it's easy to use the 9 ohm resistors. That is how you have to identify the resistor. I'm sure you all were also able to identify them and answer them correctly. So with that, I'm going to move on to the next question. The second question. The figure below shows a circuit connected with 3 bulbs. So if you like, you can highlight the points 3 bulbs having different filament resistances. The resistances are different and there is a 12 volt potential difference is applied to the 2 ends. The resistance of connecting wires can be neglected. So normally you all know connecting wires are conductors. Even the conductors have a resistance. But if you are to consider that resistance, then the calculation will become complicated. So because of that, we neglect the resistance of connecting wires. It is a small resistance compared to these resistors, all the components. The resistance of the components are somewhat high. Compared to that, the resistance of the connecting wires are less. So it can be neglected. And then the calculation also becomes a little bit more simpler. So this is very important. The resistance of connecting wires can be neglected. So now look at the diagram. Now here they have shown the 12 volt connection. You all know this is the positive terminal, negative terminal. So the potential difference across the full circuit, that is 12 volts. Then you all know when there are series combination of components, the potential difference will be divided according to their equivalent resistance. But if there are parallel combination, then of course the potential difference across the 2 points. Now here if we take these 2 points, for these 2 resistors it will be equal. The potential difference will be equal. But for this and this, it will be divided. The total equivalent resistance will be divided. Why? These 2 bulbs, you can see here B2 and B3, they are combined in a parallel combination. And then there is ammeter 1 to measure the current passing through B2, ammeter 2 to measure the current passing through B3. And then you can see this particular bulb B1 is connected in a series combination with these 2 components. Is that clear? So you have the power pack supplying the potential difference, then points P and Q are marked. Between the points P and Q, there is bulb 1 B1 with a resistance of 20 ohm. Then with that, there is a parallel combination here, B2 and B3. B2 has 6 ohms resistance, whereas B3 has 12 ohm resistance. And the 2 ammeters. So there are points Q and R. Between these 2 points is where you have this particular combination of the bulbs. Then here you can see another ammeter A3. Now the current starts flowing from here, comes up to point Q. Then at this point, the current divides. In a parallel combination, you all know the current is divided depending on the resistance. And also you all know more current will flow through less resistance. So here if you look at the values 6 ohm and 12 ohms. So more current will go through this, less current will flow through this. But then again at this point the current will combine. And all the current will flow through this conducting wire, connecting wire. So A3, that is ammeter 3, will read the current flow through the circuit, the whole current flow through the circuit. That is how you have to identify the components and you need to understand the circuit. Then, if we look at the questions. The first one, what is the equivalent resistance between Q and R? So, points Q and R, there are 2 resistors, the bulbs, connected in a parallel manner. So, what is the equation that you need to use? We need to use the equation 1 over R is equal to 1 over R1 plus 1 over R2. So, R1 we can take it as 6 ohms and R2 we will take it as 12 ohms. Now, here the denominators are different. So, what do? We need to take the least common multiple. 6 and 12, if you take the least common multiple, you will know it is going to be 12. So, here 6 into 2 times 12. So, therefore, 1 into 2, 2 plus 1 over 12. So that is equal to 3/12. Then if we calculate equivalent resistance and R, what do? You take the reciprocal of this. So that is equal to 12/3 ohms. That will be 4 ohms. 12 divided by 3, 4 ohms. That is the equivalent resistance. So look at the question. What is the equivalent resistance between Q and R? Q and R, these 2 points. So we have 6 ohm and 12 ohm. We neglect the resistance of the connecting wires. So only the 12 ohm and 6 ohms are considered. So then you need to write the equation 1/R is equal to 1/R1 plus 1/R2. So 1/6 plus 1/12. To simplify, it becomes 2/12 plus 1/12. That is 3/12. Then to find the equivalent resistance, you need to find R. Therefore, you need to take the reciprocal. So 3/12, if you take the reciprocal, you get 12/3. That is equal to 4 ohms. That is the equivalent resistance. Then we will move on to the next question. Second question. So again, the same question is given to you all. The figure below shows a circuit connected with 3 bulbs having different filament resistances. A 12-volt potential difference is applied to the 2 ends. The resistance of connecting wires can be neglected, and we have discussed the diagram before. So second question. Find the equivalent resistance between P and R. Now P and R. We have already found the equivalent resistance between Q and R. So between Q and R, what was the equivalent resistance? It was 4 ohms. That was what we calculated before. So this part has a resistance, equivalent resistance of 4 ohm. And there is a 20 ohm bulb B1. What is that combination now? It is a series combination. Once you find the equivalent resistance here, it will be like a series combination. So you can imagine this to be like this. 2 resistors. So 20 ohm, and we have found the 4 ohm resistance. So that is a series combination. Then you know what to do. You have to calculate it by adding the resistance of the resistors. So then, here to answer the question, find the equivalent resistance between P and R. You write the equation R is equal to R1 plus R2. So R1, 20 ohms plus R2, we found the equivalent resistance 4 ohm. 20 ohm and 4 ohm, 24 ohms. That is the value. Is that clear? So although there are 2 bulbs here, they are parallel, but we have found the equivalent resistance, then it acts as one resistor. You can remember, equivalent resistance means one resistance that will give the effect of the combination of the other resistors. So here, this whole part has a resistance of 4 ohm. So that is in series combination to 20 ohm. Therefore, we add the values. R equals R1 plus R2. 20 ohm plus 4 ohm, 24 ohms. Is that clear, student? So then we will move on to the next question. Again, the question and the diagram are given to you. The third one, which ammeter shows the total current? So here, look at the question. Total current passing through the circuit. So when I explained to you all, I told you this. Here you can see A1 current through B2. So this is to measure current through B2. A2 measures the current through B3. Why? Current starts flowing from here. All the current flows through B1. Then at this point, current divides. And A1 measures the current flowing through B2. A2 measures the current flowing through B3. Then both of them combine here. And then A3 measures the total current. Is that clear? So which ammeter shows the total current passing through the circuit? That is A3. If you can write it as A3, or you can say ammeter A3, or you can write the answer as ammeter A3. Is that clear to you all? I'm sure you can understand that. So then we will move on to the next question. Again, the question and the same diagram is given. The fourth part, find the total current passing through the circuit. So here again, total current passing through the circuit. So when we say total current, what are the values you need to consider? You need the potential difference. So we have the potential difference 12 volts. Then what is the resistance you should use? The equivalent resistance of the circuit. If you can remember, we calculated the equivalent resistance as 24 ohms. Just to make sure, we will go back and check. Here, find the equivalent resistance between P and R. Between these 2 points are all the resistors. So that is the total resistance or the equivalent resistance of the circuit. So that is what we need to use. So here 12 volts and 24 ohms. That is what you need to consider. Then to find the current, what is the equation? You know the Ohm's law. The equation V equals IR. You rearrange it, get the equation as I is equal to V over R. So if we substitute voltage 12 volts, resistance, equivalent resistance 24 ohms. So 12 divided by 24, that is 1 over 2. So it is going to be 0.5 amperes. 0.5 amperes. So you have to look at the question properly. Find the total current passing through the circuit. So you always have to use the equation for Ohm's law. Rearrange it, make I as the subject. Then I is equal to V over R. So here potential difference is the total potential difference. Potential difference across the full circuit, supplied to the circuit by the power source. So 12 volts. Then you need to consider the equivalent resistance of the full circuit. Equivalent resistance of all these components together. That is 24 ohms. So 12 divided by 24, you get the answer as 0.5 amperes. I'm sure you all can understand that. So then we'll move on to the next question. Again, the question, introduction and the diagram. The fifth part, what is the potential difference between P and Q? Now the potential difference between P and Q. Here we already know the total potential difference 12 volts. You know the current 0.5 amperes. The same current will flow through this as well. 0.5 amperes. And we know the resistance 20 ohms. So current 0.5 ampere, 20 ohm. Then you can easily find the potential difference. You need to use the equation V equals IR, I 0.5 amperes and resistance 20 ohms because it's only between P and Q. So 0.5 into 20, it's 10 volts. So the potential difference across P and Q or across the bulb B1 is going to be 10 volts. That also you can remember, students. I explained this to you all. Since the resistance 20 ohm, here equivalent resistance was 4 ohms. So according to the ratio, if you want, you can check that also. I told you all you can use this method to check whether your answer is correct or to find the answer for an MCQ. So 20 ohm, and for the two bulbs B2 and B3, it was 4 ohms. If you take the ratio, what is the ratio? 20 and 4, 5:1. And the total voltage is 12 volts. So if you divide 12 by 6, it's 2 ohms. So 5 ratio means this is going to be 10 volts and this is going to be 2 volts. Like that also you can find the value and you can check it easily. But here, since we have the method, we have calculated it. Is that clear? So this is based on the resistance. Since the resistance is 5:1, more potential difference for higher resistance. Why? The current flow does not change through this resistor and this component. The current is the same. So because of that, the potential difference gets divided. Is that clear to you? So here we have calculated what is the potential difference between P and Q. You use the equation V equals IR, that is equal to 0.5 amperes into 20 ohms. That's 10 volts. The potential difference or the voltage across P and Q. So with that, students, I will move on to the next question. So again, the introduction and the diagram is given to you. The sixth part of the question, find the potential difference between Q and R. So between these 2 points. Now between these 2 points, what is the equivalent resistance? We found it as 4 ohms. So earlier in the previous slide, I showed you all the calculation. 10 ohms goes to this, 2 ohms goes to this. So you can calculate it in 2 ways. The first method, we use the same equation, V equals IR for Ohm's law. So here we have the equation for Ohm's law, V equals IR. We need to find the potential difference between these 2 points. So as a whole thing, if you take this component as one resistor with an equivalent resistance of 4 ohms, then you know the current, the total current flowing through this part. It's true that current is going to divide between these 2, but in total, a 0.5 ampere current will flow into this point. 0.5 amperes, and there will be 0.5 amperes coming out. So we consider this as one component. So current is 0.5 amperes and the resistance is 4 ohms. So if you multiply 0.5 by 4 ohms, that is going to be 2 volts. 2 volts. This is the direct method where you use the equation for Ohm's law. So you can find the value. Like I told you all students, if you have to answer the question, if you have to write the answer, you have to write the equation, you have to follow this method. But let's say if it was for an MCQ. Now in the previous one, we found the potential difference across P and Q between the points P and Q as 10 volts. And from the ratio, you were able to find the rest of the potential difference across Q and R as 2 volts. Or the total potential difference is 12 volts. We found the potential difference here 10 volts. 12 minus 10, 2 volts. Like that also you can find if it is for an MCQ. But if you are writing the answer, you have to follow this method. I'm sure you all can understand that. So potential difference across Q and R, or potential difference between Q and R. We consider this full thing with the B2 and B3 and the ammeters as one component with a resistance of 4 ohms. And the current flowing through that is 0.5 amperes. So V equals IR 0.5 amperes into 4 ohms. You get the answer as 2 volts. With that, I'm going to move on to the next slide. Again, introduction and the diagram. 7th part of the question. What is the current passing through the bulb B1? Current passing through the bulb B1. We have already found that. Why? The current passing through this is 0.5 amperes. The same current will pass through this as well. So that is how the bulb B1 is connected. It is in a series connection with the power source. So because of that, all the current will pass through B1. So directly you can say the current passing through B1 flows through the circuit. Therefore, current through B1, that is I is equal to 0.5 amperes. That way also you can calculate. That is one way, because you all know all the current will pass through B1. Otherwise, you can use another method. The second method, you can use the equation for Ohm's law. V equals IR. But there, you know the resistance 20 ohm, and we have calculated the potential difference 10 volts. If you remember, in one of the previous parts, we calculated the potential difference between P and Q. That is 10 volts. So you have to use those two values only. You don't use the total potential difference 12 volts. You have to use the value 10 volts. So to calculate it, you can use the equation V equals IR. We need to find I, that is equal to V over R. V is 10 volts. R is 20 ohms. So 10 over 20, 1 over 2, that is equal to 0.5 amperes. So that way also you can find it. Now students, I am doing all the possible methods because depending on how you get the questions. Now in this question, since it is the exercise, you have all the steps included. almost all the possible questions. So we are doing similar calculations, or we are finding similar values again and again. But for a paper, for your exam, you may not get all the questions. So then, according to the question, according to the value you have already calculated, you can select one of the methods. So if you have already found the current flowing through the circuit, we use this first method. So you can say the current passing through B1 flows through the circuit. So therefore, current through B1 is equal to 0.5 amperes. If we have not calculated that, but if we have calculated the potential difference between points P and Q, then you can use this method. V equals IR, I is equal to V over R, that is 10 volts divided by 20 ohms. That is 0.5 amperes. But you all have to remember, whatever method you use, the answer will be the same, because there is only one current that can flow through B1. So with that, students, we will move on to the next question. This is the last part of the question. So again, the introduction and the diagram is given to you. And the last part. If the bulb B2 burns out, find the current passing through the circuit. Now, if this bulb B2, if this burns out, then what happens? You have a 20 ohm bulb there and a 12 ohm bulb there. So, what will happen to the circuit? Then the circuit will become something like this. I'm not including all the components, just for you all to understand. 12 volt. We have the 20 ohms, and you will have B3, B1, this is 12 ohm. So now what has happened? This part is not working, so it has become a series combination. Then what will happen to the equivalent resistance? It will have to be added together, the sum of B1 and B3. So the equivalent resistance will increase. Then the current passing through the bulb will be different. So if the bulb B2 burns out, find the current passing through the circuit. So again, you have to find the equivalent resistance and you need to find the current. So then, equivalent resistance R equals R1 plus R2. So R1 20 ohm plus 12 ohm. So that is equal to 32 ohms. Now also you can understand, students, when the combination becomes a series combination, the equivalent resistance increases further. So B1 and B3 are there, 20 ohm and 12 ohm. The equivalent resistance becomes 32 ohms. Then to find the current flow. So current flow I, V equals IR, I is equal to V over R, that is equal to potential difference 12 volts divided by equivalent resistance 32 ohms. So 12 divided by 32, you can simplify that to get, if you divide by 4, 3 over 8. So if you divide 3 by 8, so when we divide 3 by 8, you will get the value as 0.375 amperes. So that is going to be the current flow. If you can do the calculation also. 3 divided by 8, 0. So 30, 3 times 8, 24. You get 6, 60. So 7 into 8, 56. Then 4, 45. 5 times 8, 40. So that is 0.375 amperes. Now you can see the current flow has decreased further. Earlier the current flow was 0.5 amperes. Why? When the other resistor, that is bulb 2 was there, the equivalent resistance was less because there was a parallel combination as well. But now the combination has become a series combination. 20 ohm, 12 ohm and the potential difference 12 volts. So you need to find the equivalent resistance. R equals R1 plus R2, 20 ohm plus 12 ohm, 32 ohms. Then you need to find the current flow. V equals IR. I is equal to V over R, that is 12 volt divided by 32 ohms, 3 over 8, 0.375 amperes. That is the current flow across the circuit. Is that clear to you all? So, okay students. So, with this question, I have completed the questions given in your textbook. And for that matter, I am going to end this chapter at this point. And in the next chapter, I will discuss some extra questions with you all, starting with multiple choice type questions.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.